time to talk about the parabolas. There's only two of them. So two bolas, that's let me guess, it's too early on a Monday morning to try to make bad math jokes, right? Problems. These things you have played with before. Always going to be in the form of a second degree polynomial, so they're always going to have this form. There are some interesting aspects of this that we want to take a look at. Vertex and the x and y, or x-intercepts and the y-intercept is sometimes kind of helpful to have. Generally speaking, the y-intercept is going to be your starting point, because whatever we're taking a look at, we're going to be counting in some way, shape, or form starting at 0. So we want to know what nothing is and continue on from there. So it's a couple of things on this. They're either going to be increasing or decreasing. Now, this is kind of an obvious idea, but the way it's stated is a little different. You'll notice that it has f of x1 and f of x2. Well, x1 and x2 are just different numbers. They're identifying an interval on the x-axis. x1 could be 0, x2 could be 2. It could be 20. X1 could be 30 and x2 could be 50. That doesn't matter. But generally what we're looking at as we move on the x-axis from left to right, if our y values get bigger, it's increasing. If our y values seem to be decreasing, guess what? They're decreasing. Like I said, this is an obvious idea as we look at a graph, but once we take a look at this and put in the values and list it in this type of notation so that we got it very generalized, it gets a little tricky. So, if I take a look at these, on a parabola, you are always going to have part of it increasing and always having a part of it decreasing. Does that seem to make sense? And if you look at A there on the left side, if you're coming up on from the negative numbers on the x-axis, are your values for y getting bigger? And they are. Once I get on the other side, they decrease. B, if I'm on the negative side, I notice that values are decreasing. Once I get to 0 and I start going on, they start to increase. They're going up. Now, depending upon what you have here, the parabola is always going to have a vertex. It's either going to be a maximum or a minimum, meaning that either the parabola opens down or opens up. Now, it's always going to have an axis of symmetry. It's always going to have a line going through the vertex, which, by the way, will always be the x-coordinate of the vertex, such that what you see on the one side would be exactly the same as what's on the other side. So having an idea of these kinds of things helps us identify where the parabola is, what it's going to be doing, and where we're going to go. Now, axis of symmetry, like I said, what goes through the vertex will always be what x is equal to. Now, if this vertex is going through here on the x-axis and the y-axis, it's the origin, right? Axis of vertex is x equals 0 for y-axis. Now, knowing where the vertex is and knowing what other point automatically tells us where a third point is. Because of the idea of symmetry, we know where the vertex is going to be at. We know that that's a line of symmetry. So if I know the coordinates are over here, I know that there's going to be an identical one over here, reflected across the axis of symmetry. So This here has a few things on here that you definitely want to make sure that you've got. Okay? Graph of the function, ax squared plus bx plus c. This is something that you put into your notes for yourself at a later point in time. I'm just going to go over them now. There are two values out of that quadratic function that are important for us to know. And that is going to be what b and a are. Now, I want you to pay attention to this idea that I'm going to talk about for a bit. If I know what my equation is, I can find the vertex easily by putting in the value for b and a. That'll tell me exactly where I am on the x-axis. Now you're seeing this f of negative b over 2a. All that is telling you is whatever value you get here, you plug in here. It's all the same. Sort of kind of makes sense. I mean, the more of it you do, the easier it is. But having this idea that the x-coordinate on the vertex is going to be negative b over 2a helps for those of you awake paying attention. So let's take a look at a bit of an example for this one. Now, under normal circumstances, what you probably want to do is use a graphing calculator for this. But, back in my days, the dark ages, BGC, before graphing calculators, we had to know all of these ideas so that when we get a function that we can go through and graph them. So, let's see. Grid. Okay. There are a few things that I know off the bat with this. One, which way is this thing going to hold? Well, I've got a negative here, so I know that it's going to be opening down. If it's positive, it opens up. I also happen to know that this here is going to be the y-intercept. If x is 0, it's got to go through at 0.6. 1, 2, 3, 4, 5, 6. Now, this could be the vertex. This could not be the vertex. I don't know. That's where this x is equal to negative b over 2a bit comes in. So if I want to know where the x-coordinate is on the vertex, well, what's b? B is negative 4, so it's going to be minus negative 4 over 2 times, and what's A? A is negative 2. Make sure that you put in the sign that goes with it. That's why I told you back when you guys were in algebra. Always put a parenthesis around it when you replace the variable with the value. So, now it looks like this is going to end up being, well, that's going to be 4 over negative 2, or negative 4, sorry. So this just turns out to be negative 1. So I know somewhere on here, where x is negative 1, back here is where the vertex is going to be for this thing. I also know that it happens to be going or opening down, correct? And since the vertex is on this side, it's going to have a shape kind of like this, right? Would that make sense? If the vertex is over here, it's got to go down this way and down that way. Where it is yet, I don't quite know, but I know it's going to be on the x, one line. So, if x is at negative 1, that is where the vertex is going to be. All I have to do is put any value weighted this thing. 4, -1. So let's see, -1 squared is 1, yes? Times -2, well, that gives me -2. This gives me +4. +4 plus 6. So when I do the math here, that means it's going to be at 8. Would you agree? Yes? Maybe so. So that means the vertex, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the vertex. Now, because I know that through the vertex is the axis of symmetry running down, so I know that I have something running there as my axis of symmetry, correct? Would that mean that if I got a point over here, that I've got a point over here? Would that track? Yeah. Now, you've got enough information here to kind of draw out where things are going. So I know that it's going to be heading down this way. I know that it's going to be heading down this way, kind of curves down. The only other thing that I would like to know right now is where it goes through the x-axis. How do we find that? Now, remember when we were talking about factoring last week? This idea of factoring and finding zeros in that is what we need to do. So, okay, erase this stuff out of here. So I'm going to look at factoring this thing. Could I factor out a -2 all the way through this thing? So that would give me x squared plus 2 plus 3. Would you agree? It's a messed up sign. Got that. Is that better? Remember, if I factor out the -2, this negative goes to a positive, that negative goes to a positive, that positive goes to a negative. So now I know it's going to factor out. As follows. Next. One that's positive, I got one that's negative. So what factors of 3 do I have to use? Well, the only factors of 3 you got are 1 and 3. So that means 3 goes here and 1 goes here. Now, there is one more step with this. In order for this to be going through the x-axis, that has to equal 0. So x plus 3 is equal to 0. Subtract 3, x is equal to -3. X is equal to 1. Correction, I screwed that up, sorry. X minus 1 is equal to 0. Add 1, x is equal to 1. So if I plug in -3 here, -3 plus 3 goes to 0. That's where it goes through the x-axis. So, 1, 2, 3. 1. Right? Yep. So, my question for you is my symmetry still there? If the line of symmetry comes down here, 1, 2, 1, 2. So I know that it held it and things are working good. So I know that my parabola is going to look something like that. Okay? That's what the parabola is. Now mind you, you can plug any values in for x down, figure out where the other things are at. But this process here identifies where it goes through the x-axis at. So knowing the vertex, the y-intercept, and where the x-intercepts are, pretty much goes and gives you a pretty good picture of what the parabola is. So, if I take a look at what they had done here, we kind of went through that. They got that they talk about on a spreadsheet. Now, is it possible to put this stuff on a spreadsheet? Well, most definitely. You end up having to create a table, with the numbers on it and where it goes. Spreadsheets are fine. If you don't have a graphing calculator, that's one possibility. Okay? So, let's talk about this example here. Maximizing rate, which is always a good thing if you're selling a product, right? So, let's talk about this. Suppose the monthly revenue from the sale of a Carlson 42-inch 3D television is given by the function. So for every thing they sell, they make money off, right? Which way does this parabola open? Does it open up, or does it open down? Down, that negative front. So it wants us to find the vertex and the axis of symmetry of the graph of this function. Now, this is our A, this is our B, and do we have a C? No, there's no constant vector, so we don't have to worry about that. So the first step for finding the vertex is, x is equal to negative b over 2a. So that means I'm going to put in negative, what's b? 600. So I get minus 600 over 2 times, what's the value for a? Well, that's going to be negative 0.1. Now, would it make sense to sit there and do that by hand? Well, not necessarily. I know that it's going to be positive. I know this cancels out and goes to 300. So really I got 300 over 0.1. Decimal point over here, decimal point over here. So, vertex is going to be at 3,000 units. That makes sense. Does that seem plausible? Yes, I believe so. So, it says determine if the vertex represents a maximum or minimum. Now we said this thing opened which way? Up or down? No, because of this negative right here. So if it's going down, that means it's got to be a shape that looks like this, right? So that means this vertex up here has to be a maximum. Okay? So, if that is a maximum, now it wants us to interpret the vertex in the context of the application. So if it is a maximum, that means I have to sell 3,000 X's. And the X's are the dollars or the units of televisions. Generally, if you're selling something, are you selling dollars and collecting TVs? Or are you selling TVs and collecting dollars? If you think about it in those terms, that's got to be 3,000 TVs, like I had said before. So, if I were to go and put this into the calculator, well, seeing that I don't feel like actually multiplying all of that out, this, put you there. So that means that I would end up getting, let's see, negative 0.1 multiplied by, let's see, that would have to be 3, 1, 2, 3 squared, correct? Yes? That might be it, right? Plus 600 multiplied by 3,000. Did I set the equation up correctly? and I put the numbers in there. And if I did, and I hit enter, that tells me that I am going to make that. So that means that if I sell 3,000 TVs, I should make, my revenue should be equal to $900,000. Now, we're going to graph this one. When you guys are graphing, you generally have a problem trying to figure out what that blasted window is, right? What do I set the numbers? Now, knowing where the vertex is going to help us out immensely. So, take this negative 0.1x squared, let's see, plus 600x window. Now, what is the minimum number of TVs that I can sell? Well, that'd be 0, correct? I can't sell negative TVs. So that's going to be 0. Maximum number. Now, if the vertex represents a point halfway through, and I want to make sure that I have my graph large enough for the x inputs so that I can see the whole thing, what would be the smallest number I'd want to put there? Anybody got a clue? If I want to be able to see as much of that graph as possible, and the vertex is at 3,000, 6,000, double, move it up, right? So, I'll put it in here as 6500. Why? Just so that I got a little gap on there. Why minimum? Now this I am going to leave at -10 because it gives me a better picture when I have the graph up there as to where the axis is at and when it's being crossed. Okay? Maximum. So if I've got a parabola, and I just figured out that if I sell 3,000 units, I make $900,000. Does Y represent the dollars that we bring in? So if Y represents the money we bring in, would I want to set my Y value above $900,000? Would that be a reasonable assumption to make? So if I go and take 9, I'll go 9, 1, 0, 1, 2, 3. So when I hit graph here, I should see the parabola in the first quadrant. It goes up, down, and I get to see where things are at. Okay. Is that a good graph? So it says for what values of x is the function increasing? Now the functions, we're selling more and more and more and more going up this way, right? So that means that we are increasing on, let's see, from 0 to how much? 3,000. So on that interval, we are increasing. When we are on the interval of 3,000, comma, how many? 6,000. We are going to be decreasing. Doesn't quite make sense that if you make 6,000 TVs, that it goes down, does it? You think the more TVs you sell, the more money you make, right? For whatever reason, their function says that this is what happens with their TVs. Maybe it's market saturation. So, sort of kind of makes sense. But when you are doing these problems, think about them in a real way. Don't just treat it like something, well, I don't know what's going on here with it. You're selling TVs. It's kind of easy to figure out what's happening to it. So, let's see. All right. This is a classic. I can almost guarantee, almost, that this type of a problem you would see on an ACT test or the MCA2s. That quite creepy. So, a ball is thrown upwards at 64 feet per second from the top of an 80-foot high building. There is something that you need to make sure that you write down into your notes. This little thing right here. Come on. That's not what I wanted you to do. Gotcha. Now, what goes where? Okay? Your starting velocity is right there. Kind of V sub 0. I mean, that V for velocity, does that make sense? Whoops. Initial height is right here. Now, this negative 16, that is going to be if you are dealing with things in feet per second. Okay, that's the force of gravity when we're dealing with things in feet per second. Okay? If you are dealing with things in meters per second, that would be a different number. And you notice it's negative because which way is gravity moving? Down. So, if I know these things, it wants us to write a function based upon the information that we've got here. So that means that this function here, f of x, is going to be equal to negative 16x squared plus, what is its initial velocity? What would that be, 64 feet per second? That's how fast it's going. 64x plus, what's the height of the building that you're on? 80. So that's where it started. Now it wants us to find the t and s, the seconds, of the vertex of this thing. Okay, so where's the vertex going to be? Oh, the vertex is going to be where the vertex always is, at negative b over 2a. So this is going to be at negative 64 over 2 times negative 16. So those cancel out. That turns out to be 32. So that means that this thing is 64 over 32, which means it's going to be at 2. So 2 seconds into this, throwing this ball, it maxes out, hits its vertex. Is that reasonable? Think about what happens. So if it's 2 seconds in, what's the height going to be? Well, it's going to be 4 squared, or 2, which is going to be 4, correct? 4 times negative 16 is negative 64, correct? Yes? So I've got negative 64. Put in 2 here, 2 times 64, that's 128, correct? Plus 128 plus 80. So that means that I got 64 plus 80. So that means the height of this thing should be at 144 feet. So now I know the highest this thing is going to go is 144 feet. And I know that it's going to be 2 seconds after the beginning of it. So they want us to graph this model. So back here, y is equal to, out of there, put in negative 16x squared, I said squared, plus 64x plus 80. Window. Okay. We're talking in seconds. Do I really need 6,500 seconds? Probably not. Would 10 seconds probably be more than sufficient? And the answer probably is going to be yes. Considering it reaches its apex at 2 feet, or 2 seconds again. It's got 8 more seconds to go, but then again, we were already 80 feet high. So we'll give it a little. Again, I'm still going to leave y minimum at negative 10. What should be my maximum height? Well, the vertex is supposed to be at 144. Would 150 be sufficient to graph? So we hit graph. Now, this is not a graph of where the ball lands. Okay? This is not height and distance. A lot of people always think that, oh, that's what the path of the ball looks like. This is the height of the ball based upon time. It is not the height of the ball based upon distance from the building. That's a completely different equation. Now, we know that that's the height. What would this represent down here? Well, that would represent when it hits the ground, correct? Now, if I do a trace on here, automatically came up on me this time. After 5 seconds, y is equal to 0. So could I go and make the statement that it takes 5 seconds to hit the ground? And the answer would be yes. Now, sometimes it works out nice and easy, other times not. Now, could have I gone through and factored this thing out up over here to figure out what that is? And the answer would be yes, I could have. Only the positive value would have been the one that actually made sense for us. So, another form that we use is vertex form. If you have it in this form, it tells you automatically where the vertex is. You don't have to do any calculation. This takes a little bit more to get it in this form. Okay. But generally speaking, you're able to go and do the calculations on that. So that's another piece of information that you should make sure that you try and have written down in your notes. So, let's see. So if I just be looking at this real quick here, if it's in this form, I know exactly where the vertex is. Vertex is going to be 40 and 200. Automatically pops right out of it. The only thing I'll caution you on is make sure that this is negative. There's some reasons for that we'll be going over later, but make sure that you put this one into your notes as well so that you have it to work with. So I'm going to let you guys start on